This video is going to go over Module 4 Homework 2 notes, which is about complex numbers. So we're going to start off with imaginary numbers. So we have I. I is like our special case with radicals. I is going to be the square root of -1. Then that's just kind of like our special case. It's a rule, so make sure that you memorize I is the square root of -1. Only special case, only weird thing, only thing to memorize. That's like a fact like that. So, side note, if I have I as the square root of -1, if I were to square both sides, I would get I squared equals, the square root and the square will cancel each other out because they are opposite functions, so we're just left with -1. So I squared will give us -1. We have a definition. A blank number is one that can be written in the form A plus BI, where A is this real part, and the B is the imaginary part, where A and B are just some real number, doesn't matter what it is. And this is what's called a complex number. So complex numbers are written in the form of A plus BI. So it's a real part plus an imaginary part. Together will make different parts, so a complex number. So what is the imaginary part? That's going to be our A value. And then like we said, the B value is going to be, oops, I did that backwards. Our real part is A, and the imaginary part is that B. Because the imaginary part has the I with it. So we want to, for our first example, write 6 plus 4i in standard form. Remember, standard form is that A plus BI. So where A is separate, plus B is separate, and then I is separate. So that means I have 6 plus 4i divided by 2. That means I can split this up and I can write both terms over 2. So 6 over 2 plus 4i over 2. 6 divided by 2 will give us 3, plus 4 divided by 2 will give us 2i. So 3 plus 2i. This is in the form of A plus BI. So that's our final answer. Now let's simplify the square root of -45. So let's break this down just like we did every other one. I'm going to start by breaking down that -45 into -1 times 45. Because I know that -1 is our special case. So I'm just going to circle it. We'll come back to it in a second. 45 we know is 9 times 5. 9 is 3 times 3. 3 gets circled, 5 gets circled, so boom, we simplified it completely. So we know the square root of -45 is the same thing as saying the square root of -1 times 3 times 3 times 5. Now that square root of -1, that's our special case from up there. We know it's going to be our I. Again, only special case, only weird thing. It's the square root, so we're taking out 3 of a kind like usual. So those two threes are coming out. And that poor little lonely 5, it's by itself, so it's going to stay underneath the radical. So my final answer, I times 3, which we write as 3i square root of 5. Again, the square root always goes last. Next example. This time I have a negative inside and a negative outside. So negative square root of -147. So I'm going to rewrite this again as -1 times 147. The -1 is my special case, so it's going to get circled. 147 is 3 times 49. So 3 times 49. 3 is gonna get circled. 49 is 7 times 7. So those get circled. By the way, you could have also did 147 was 7 times 21. And if you would have broke that down, you would have still got the same 3 times 7 times 7 breakdown. So no matter how you break it down, that's totally fine. So I have this -1 out front, it's going to stay out front. Underneath the square root, we said we had -1 times 3 times 7 times 7. So again, notice this negative was out front and it stayed out front. And then underneath the square root, we had the -1 times 3 times 7 times 7. So that -1 is just out front. It's going to stay out front and just come down. I have the square root of I, which is our square root of -1, which is our special case of I. It's the square root, so we're looking for 2 of a kind. So those two 7s are going to come out, and then the poor little lonely 3 is left by itself underneath the radical. So up front I have -1 times 7 times I, which is -7i, and then the square root of 3. So our final answer is -7i square root of 3. Next page. All right, so example, perform the indicated operation and simplify. Express your answer in terms of I as a complex number. The square root of -3 times the square root of -48. This one is kind of weird, so I wanted to go over it together. They're both square roots like we talked about on the previous homework section, so I can write it underneath the same square root. -3 times the -48. I don't want to put them together because then my whole point in here is to break this apart. So I have -3, so -1 times 3, -1's going to get circled, 3 is going to get circled, -48 is -1 times 48, -1's our special case, it gets circled, 48 is 2 times 24, 2 is going to get circled, 24 is 2 and 12, 12 is 2 and 6, 6 is 2 and 3. So you broke it down until it cannot be broken down anymore. So that means underneath my square root, I have 2 -1s. I have 1, 2, 3, 4 2's. And then I have my 2 3's. So I have my 2 -1s, 1, 2, 3, 4 2's, and then my 2 3's. All underneath the radical. It's the square root, so we're looking for 2 of a kind. So these 2 -1s are coming outside of the radical. These 2 2's are coming outside of the radical. These 2 2's are coming outside of the radical. And these 2 3's are coming outside of the radical. So outside of the radical, I have -1 times 2 times 2 times 3, which is -12. Nothing's left underneath the radical, so the radical goes away. Done. Notice, if I were to multiply these together, the negative times the negative would have canceled each other out, but we needed them in our answer. So don't multiply them together. Go ahead and break them down. So that way you get your final answer. Next example. Simplify the square root of -1 divided by the square root of -1 times the square root of -6. So I have the square root of -1 on the top, square root of -1 on the bottom. Those are going to cancel each other out because it's the same thing on the top, same thing on the bottom. So we're left with 1 over the square root of -6. Before we do anything with that, remember I cannot have a radical in the denominator. So I need to rationalize my denominator. I need to get that radical out of the denominator. So in order to do that, I can multiply the top and the bottom by the square root of -6. That means up top I have the square root of -6 times 1, which is the square root of -6. On the bottom I have the square root of -6 times the square root of -6, which is the square root of -6 twice, which is the square root of -6 squared. So the square root and the square will cancel each other out. We're left with the square root of -6 up top, and then just -6 on the bottom. Side note, simplifying the square root of -6, I have -1 times 6. -1's our special case, so it'll get circled. 6 is 2 times 3. So I have the square root of -1 times 2 times 3. The square root of -1 is our special case. That's going to come out as I. But underneath the radical, I still have 2 times 3, which is 6. So I really have, where's my blue? I square root of 6 over -6. And that is our final answer. Let me just double check 100%. Well, I have it pulled up, but that's exactly how the homework wants it. 1 second. Yep, that's exactly how they want it. The only thing that they did kind of different here was instead of taking that negative on the bottom, we talked about this the very first day of class, we can write it on the top, on the bottom, or out front, and either way it's just a negative fraction. So they wrote it out front, and they wrote square root of 6 over 6, that's a number, and then they wrote their I out here. It's the same thing, so either way would be marked correct. They just wrote it as the number, and then they wrote the I separate. It's the same thing. Here the I is up top. Here the I is still up top, but they just kind of wrote it separately. So either one is exactly the same. Next example, express the square root of negative 100 minus the square root of negative 64 as a complex number in terms of I. So, the square root of negative 100, I have negative 1 times 100. Negative 1's our special case. I know that 100 is 10 times 10. That will give me a 2 of a kind. It's a perfect square. So if you want to go ahead and break down 10 into 2 times 5 and 10 into 2 times 5, go for it. You're going to get the same answer in the end. But I know 100 is a perfect square. It's 10 times 10. That will automatically give me the 2 of a kind that I'm looking for. Same thing over here. Negative 64 is negative 1 times 64. Negative 1's our special case that gets circled. Again, we know 64 is a perfect square. It's just 8 times 8. So underneath the square root of negative 100, I have the square root of negative 1 times 10 times 10. The square root of negative 1's our special case, so it's an I. I have 2 10s underneath the radical that are coming out of the radical. So that means the radical is going to go away because there's nothing left underneath. So I times 10 will give us 10I minus the square root of that negative 1 times 8 times 8. So bringing down that minus, square root of negative 1 will give us an I. It's square roots, we're looking for 2 of a kind. So those 2 8s are going to come out. So minus 8I. So now I have 10I minus 8I. These are just both i's. These are like terms. So if I have 10i's minus 8i's, that will leave me with 2I as my final answer. Next example, evaluate the expression 4 plus 2I plus 6 minus 7I. Write a result in the form of A plus BI. So there's nothing outside of this first set of parentheses to distribute besides a positive 1, so it's going to stay 4 plus 2I. Now, outside the second set of parentheses is a positive 1, but so likewise it's going to stay plus 6 minus 7I. Combining like terms, just like if those were x's, I have 4 plus 6. Those are just numbers. Those are like terms. 4 plus 6 will give us 10. And then I have 2 minus 7i. Those are like terms. So if I have 2i's minus 7i's, that'll give us negative 5i. So my final answer is 10 minus 5i. So this is in the form A plus BI, so we can see that our real part is A, so the real number A equals 10, and the real number B will give us negative 5. Negative 5, so it's minus 5i. And then that was our last page. All right, so perform the indicated operation. And simplify. 16 minus the square root of negative 100 minus negative 6 plus the square root of negative 49. So before I even do this, I'm going to have 16 minus the square root of negative 100. Well, I know the square root of 100 is 10. Then the square root of that negative will give us that I. So that's outside. Minus negative 6 plus same thing here. The square root of negative 49, well, the square root of positive 49 will give us 7. And the square root of that negative 1 will give us the I. So the square root of negative 49 is really just 7I. Now this is kind of simpler for us to distribute. There's nothing outside of this first set of parentheses to distribute, so it's going to say 16 minus 10I. Let's go ahead and distribute that negative that's out front of the second set of parentheses to both terms. So negative times a negative will give me a positive 6. Negative times a positive will give me a negative 7I. Combining like terms, 16 plus 6 will give me 22. Oops. Yep. 22. And then I have negative 10I minus 7I. Those are like terms, just i's. Negative 10 minus 7 will give us negative 17I. These are not like terms, we cannot combine it. It is in A plus BI form, so that's our final answer, 22 minus 17I. Next example. Perform the indicated operation and simplify. Express our answer in terms of I as needed as a complex number. 5I times negative 2 plus 7I. So we can distribute 5i times negative 2. Think of the I like an x, the same thing you would do here. So my numbers, 5 times negative 2 will give me negative 10. Then I have an I. 5i times 7i. 5 times 7 will give us positive 35. I times I is I squared. Going back to this page, remember that I squared is negative 1. So I can rewrite that as negative 10i plus 35, and we know I squared is negative 1. So negative 10i, 35 times negative 1 will give us negative 35. Remember, it needs to be in the correct form, a plus bi, where the I goes last. So it's the same thing as saying negative 35 minus 10i. Now this is in the correct form of a plus bi, so that will be our final answer, negative 35 minus 10i. Last two, and we're done for this notes packet. So simplify, negative 4 plus 5i times negative 4 minus 5i. Going back, remember whenever we were distributing terms that have the same thing, over here. We were distributing, we multiplied these two things. They were exactly the same thing, they were just different middle signs. Well, we now know that that's called a conjugate. They're the same things with a different middle signs. Whenever we multiply two conjugates, the middles canceled out. So same thing should happen here. These two are conjugates, negative 4 plus 5i, negative 4 minus 5i. They are conjugates, they're the same thing with a different middle sign. So whenever we multiply conjugates, the middle should cancel out. Let's just go distribute as usual. So negative 4 times negative 4 will give us positive 16. Negative 4 times negative 5i will give us plus 20i. So we did negative 4 times everything. Now 5i times everything. So 5i times negative 4 is negative 20i. 5i times negative 5i will give us negative. 5 times 5 is 25. I times I is I squared. Now we know we did it right because those conjugates, those middles do cancel out. 20i minus 20i. They cancel out. Perfect. Great. So I have 16 minus 25. And again, we know that I squared is negative 1. So I can rewrite I squared as negative 1. So I really have 16. Negative 25 times negative 1 is positive 25. And then our final answer is 16 plus 25, which will give us 41. Done. Oh, sorry. 41. Last one. All right, so simplify the following expression. Negative 8 plus the square root of negative 4 divided by 6. Write our answer in the form a plus bi in standard form. So I know that the square root of negative 4, well, the square root of 4 will give us 2. The square root of that negative 1 will give us I. So I know the square root of negative 4 is the same thing as saying 2i. So I can rewrite this as negative 8 plus 2i over 6. Now I want to write it as a separate plus b separate and then I separate. So I can separate this just like we did on that first problem and say negative 8 over 6 plus 2 over 6i. So now it's in a plus bi form. And then now we can simplify. Negative 8 and 6 both have a 2 in common, so I can factor or divide out a 2 from the top and the bottom. And we're left with negative 4/3. So negative 4 over 3. Same thing, 2 over 6. They both have a 2 in common, so I can factor or divide out that 2 from the top and the bottom. And we're left with positive 1/3 I. And this is our final answer. These are not like terms, so this one has an I and this one doesn't, but it is in the correct a plus bi form. So our final answer is negative 4/3 plus 1/3 I. And we did it. This is Module 4, Homework 2 Notes. Thank you for watching.